Welcome to the session on security at the edge. I'm Ryan D'Souza, and I'm a principal solutions architect at AWS. I'm so pleased to be here today. Let's go ahead and take a look at the agenda. So as we take a look at the agenda today, I'm going to start off with a brief introduction to the industrial edge. We will then get into two cybersecurity edge use cases. The first use case is data exfiltration use case. So data is being exfiltrated from the factory, and we want to detect that. The second use case is a cryptocurrency mining use case. In this use case, we will discuss how a cryptocurrency miner has compromised the edge device and is using the edge device for cryptocurrency mining. We'll then talk about how AWS services can be used to secure the industrial edge. And I'll finally come back and we'll do a wrap up. We've got a lot of content to cover today, so let's get started. So having worked with industrial customers from around the world, we've seen that industrial customers want to run industrial applications in different places. They want to run industrial applications in the factory. Some of them want to run industrial applications in the cloud, and everywhere in between, whatever makes most sense for their business. AWS offers customers a continuum of services from cloud to edge in order to support low latency and local data processing requirements. Let's take a look at some of these services. On the left-hand side, you've got the AWS Cloud and AWS regions, and this offers customers the full scale, the full elasticity and service offerings for industrial applications. This is suitable for many use cases, but not all industrial use cases. There are some industrial use cases where data needs to be processed at low latency and processed locally in the factory. To support these low latency and local data processing requirements, AWS offers other services for industrial customers that you can see in the center and right-hand portion of this slide. Let's go ahead and discuss some of these services. The first is AWS Outpost. AWS Outpost extends AWS infrastructure and AWS services to on-prem locations. So it offers local storage, local compute, and local services that run on the customer premise. Outpost is available in different form factors. You can have 1U and 2U Outpost servers. You can have 42U Outpost racks, and you can even have multiple racks if needed. AWS also offers a new kind of infrastructure called AWS Local Zones. AWS Local Zones can be used for low latency applications close to metro centers. AWS also offers customers AWS Wavelength, which is AWS infrastructure and services that run within the 5G network for low latency applications to 5G devices. On the right-hand side is what we call the ruggedized edge and the disconnected edge. At the bottom, you can see we've got, bottom right, you can see we've got snowball and snow cone devices. These are appliances like the one I have here. So these are ruggedized edge devices that can operate in a disconnected mode. They can run AWS services on-prem at the customer location and can process data locally at low latencies. On the top right of this slide, you can see that we've got our other services, which include AWS IoT services, robotic services, and AI ML industrial services. These services can be used to process OT data or operational data in the factory and at the customer location, again for low latency and local data processing requirements. So with that, let's go ahead and discuss what exactly is the industrial edge. So the industrial edge is a local storage and compute platform. It operates within the four walls of a factory or an industrial facility, and it extends AWS cloud services down to these environments and these locations. Industrial edge computing enables OT data or operational data to be processed at low latency and locally in the factory and close to the machines that generate this data. And it is needed in several different industrial scenarios. The first scenario is there may be no internet connection, or there may be very limited network connectivity. An example could be an oil rig in the middle of an ocean that uses a satellite connection to connect to the cloud. In some cases, it may be too expensive to send vast amounts of data over a satellite connection to AWS, and you need to process that data locally. In addition, there may be other use cases where data cannot be transferred off-site and needs to be processed locally at the site in which the data is generated, due to either security or data privacy concerns. An example over there would be hospital and healthcare facilities. And finally, you may have devices and use cases that need to process the data and make split-second decisions, like in robotic surgery. In this case, also, data needs to be processed locally at lower latencies. So let's talk about some of the challenges associated with edge computing. Industrial edge computing is driving the next wave of cloud computing and is governed by what AWS calls the 3 laws of edge computing. The first law of edge computing is the law of physics. This is the amount of time it takes to send data to the cloud and get a response back. The second law is called the law of economics, and the law of economics determines the cost effectiveness to send vast amounts of data from on-prem locations to the cloud for processing. And in some use cases, it may be too expensive to send all the data to the cloud for processing, and it makes more sense to process that data locally. The third law of edge computing is the law of the land. And the law of the land deals with or regulates where the data is processed and where the data is stored. As we discussed earlier, there may be security concerns or data privacy concerns where data needs to be processed at the location that generates the data, and it cannot leave the facility. In that case, the law of the land applies. So as you can see, it is either for low latency applications or applications where data needs to be processed locally and stored locally, where edge computing makes the most sense. So now let's discuss the industrial edge and the different AWS products and services that provide compute and storage at the industrial edge. If we take a look at this slide, we've got at the left-hand side, we've got the line side. The line side means these are edge devices that either are installed on the factory, on the machines, or very close to the machines in the factory. In these cases, we've got a number of partner devices that can run AWS Edge software. There are situations where customers may want to run AWS Edge software on their own virtual machines. There are other cases where customers may want to use a snow cone device. So this is a snow cone device. As you can see, it's a ruggedized edge gateway or an edge appliance. It can run AWS Edge software. It can operate in a disconnected mode. It offers local compute and storage, and it is great for a number of industrial applications for edge computing. There may be situations where customers may need more compute capabilities than the small snow cone device. So if customers need additional compute and storage capability that is not available on the snow cone device, the customers have the option to use the Snowball Edge device that you can see at the center of this slide. On the right-hand side, we've got the AWS Outpost family. The AWS Outpost family includes 1U and 2U Outpost servers and 42U Outpost racks. And these racks, you can have multiple racks depending on the local compute and storage that you need for your industrial applications. So as you can see from the slide, AWS offers customers lots of different options, lots of different flexibility for compute and storage at the industrial edge. So now let's go ahead and discuss security at the edge and some of the design considerations when you design an edge security solution or an edge solution. You need to ensure that you're designing security into the solution and you have security at scale, since you may have a number of these edge devices and edge computers. So thinking about how do you secure at scale is going to be very important. You've got to ensure that the edge device or the edge computing platform is performing only the defined actions. It can access only defined resources. It always reports its current state and always stays recoverable. So these are some of the design considerations when it comes to securing industrial edge computing. So now let's go ahead and take a look at our industrial IoT security architecture. So as you can see in this industrial IoT security architecture, it is aligned to the Purdue model. So if you're familiar with the Purdue model, you can see the different layers at the bottom of the slide. Layer 0 is your industrial machines. Layers 1 and 2 is your industrial automation and control systems. Layer 3 is where you place your manufacturing execution systems. You can see that layer 3 is also the industrial edge. So all the services that we spoke about earlier in terms of snow cone devices and snowball devices, outpost servers, AWS IoT Greengrass, AWS IoT Sitewise Edge, all the different AWS edge services that AWS offers industrial customers operate at layer 3, which is what we call the industrial edge. Between layer 3 and layer 4, you're crossing the OT-IT network boundary. When you cross the OT-IT network boundary, it's important to secure that boundary, and we secure that with an IDMZ, or an industrial demilitarized zone. From layer 4, you can see there are different ways you can securely connect to the AWS cloud. You can use site-to-site VPN, or you can use Go over Direct Connect. You can also traverse the public internet and connect to various AWS IoT services in the AWS cloud. In the AWS cloud, you can see we've got a number of security services that can be used to secure your industrial IoT solutions. So with that brief introduction, let's dive into the two use cases that we're going to discuss in today's session. These are both cybersecurity use cases. The first use case is data exfiltration from the factory. So data is being exfiltrated from the factory, and we want to be able to detect this data exfiltration. As you can see in this architecture, we've got the factory on the left-hand side. We've got the AWS cloud on the right-hand side. In the factory, we've got CNC machines, or computer numerical control machines, that generate sensor data. This data is sent over OPC UA to an edge gateway. The edge gateway is the industrial edge, and that's the gateway device that you can see in this architecture. It runs AWS IoT Greengrass and other AWS software like AWS IoT Sitewise Gateway that can process data locally at the edge and then send that data to the AWS cloud. You can also see that there's a malicious script on the edge device. So the edge device is compromised, and data is being exfiltrated from the edge device and from the factory. And this is what we want to detect in this first use case. So in this use case of data exfiltration from the factory, you can see we've got the edge gateway in the factory at the industrial edge, and we've got the AWS cloud on the right-hand side. We can also see that data is being exfiltrated to a malicious website, which is what we want to detect in this use case. So what we're going to do is we're going to use AWS IoT Device Defender. AWS IoT Device Defender running on the edge gateway is going to monitor the edge gateway. It's going to send device-side metrics. So AWS IoT Device Defender provides device-side metrics. These device-side metrics are sent to the AWS cloud, to the AWS IoT Device Defender service, and you can monitor the edge gateway using the AWS IoT Device Defender service. So what exactly are we going to monitor? We're going to monitor three metrics, which are called device-side metrics. It includes packets out, bytes out, and destination IP. So packets out and bytes out is the amount of data that is being sent from the edge device or the edge gateway. Destination IP is all the devices that the edge gateway connects to. So what we do is, using the AWS IoT Device Defender service, we create a security profile. In the security profile, we define the normal bytes out, the normal packets out, and the destination IPs that the device connects to. So in step one, we create a security profile using the AWS IoT Device Defender service, and we monitor for bytes out, packets out, and destination IP. As soon as we see a change or an anomaly in bytes out, packets out, and destination IP, we immediately get an alert that there's something unusual happening with the edge gateway. So let's take a look at that. So as you can see, we are monitoring three metrics: bytes out, packets out, and destination IP. You can see that when we get a spike or an increase in bytes out and packets out, it means that data is potentially being exfiltrated from the factory. Destination IP will give you an indication of where is this data being exfiltrated to. So we are using AWS IoT Device Defender device-side metrics, the standard metrics, in order to detect an increase in the volume of data that is being exfiltrated from the edge device, and destination IP gives you an indication of where this data is being sent to. So that is the first use case. So now let's take a look at the second use case, second cybersecurity use case that we have for today. So the second cybersecurity use case is cryptocurrency mining. Now, edge devices and edge computers may have processing capabilities with a GPU device, and this processing at the edge, the capabilities that the edge device has, can attract cryptocurrency miners. So you may have cryptocurrency miners that may compromise an edge device and take advantage of the vulnerabilities on the edge device. So what we're concerned about in this use case is we've got an industrial computer vision use case. So in this industrial computer vision use case, we're doing quality inspection of product in the factory. We've got a GPU hardware on the edge device that is doing the GPU processing of the machine learning models at the edge. So you can have machine learning run on the edge device. It is also called as ML at edge. And what we're monitoring over here is GPU load on the edge device, as well as the average inference time. So average inference time is the average time it takes basically to make an inference at the edge for this industrial computer vision use case. So in this case, what we're doing is we've created two custom metrics. Okay, these are called custom metrics because GPU load and average ML inference time are custom metrics for AWS IoT Device Defender. We capture these custom metrics on the device. We send it to the cloud to the AWS IoT Device Defender service, and AWS IoT Device Defender is then used to monitor any anomalies on the device. So as soon as there is a change in either GPU load or average inference time, it's an indication that the device could be compromised and could be used for cryptocurrency mining. So let's take a look at that. So you can see over here, we are using AWS IoT Device Defender in order to monitor the edge device. We are using custom metrics, which is GPU inference time, as well as the GPU processing load and average inference time. We're also using some additional metrics like destination IP, listening UDP ports, and listening TCP ports. So when we set up a security profile, which defines what the normal behavior of the device is, and AWS IoT Device Defender is then going to monitor for any anomalies in any of these parameters or metrics. So as soon as there is an increase in GPU load and there's an increase in the average inference time, it could indicate that the device is compromised and is used for cryptocurrency mining. So the two services or the service that we used for these two use cases, the data exfiltration from the factory and cryptocurrency mining on the edge device, the service that we use for monitoring these edge devices is AWS IoT Device Defender. So AWS IoT Device Defender is a security service. It is used to audit and monitor your fleet of edge devices. With audit, it audits the security policies associated with your devices to ensure that they aren't deviating from security best practices. With detect, we are continuously monitoring the behavior of the device. There are two ways you can set the normal device behavior. You can either create a security profile, or you can use machine learning to set the security profile. So AWS has made it easier for customers by bringing machine learning to AWS IoT Device Defender in order to set the device profile for you automatically using the data collected. Once you get an anomaly, or once an anomaly is detected by the service, you get an alert, and based on that alert, you can then take mitigation actions. There are different mitigation actions you can take. You may want to quarantine a device and isolate the device for further investigation. You may want to revoke a device's certificate and disconnect it from the platform. So you have a flexibility to take a number of mitigation actions with the AWS IoT Device Defender service. So the next thing we're going to talk about is security monitoring across edge and cloud environments. So traditionally, security monitoring solutions in the factory have been very isolated and very siloed. So you had security monitoring at the edge and security monitoring in the cloud. You had security monitoring in your operational technology or OT networks. And it's important to monitor security across the attack surface and across the threat landscape. So with Security Hub, it enables you to bring in security events from operational technology, from your edge and the cloud in order to get security events in a single place. And you can use Security Hub in order to better understand your security posture and improve the security posture across edge and cloud environments. So with that, let's take a look at the different AWS services that can be used to secure the industrial edge. You can see that we've got a number of different AWS services that can be used to secure the industrial edge. This is aligned with what we call as the 10 security golden rules for IIoT solutions. It is available as in a blog post as well as in an IoT security white paper. And that's the different numbers on this slide, which basically map to one of the security golden rules. So if I walk across and I review this slide, what we can look at in golden rule number 2 is to have a connected asset inventory. So in order to secure your edge devices, you first need to know what are your edge devices and how these devices are interconnected. And that is in a connected asset inventory. You can use AWS IoT Device Management as well as Systems Manager in order to get an inventory of your edge devices and edge gateways. For identity and access management, you can use AWS IoT, IAM, as well as Cognito. You need to patch and update software on your edge devices and apply security fixes. So you can use AWS IoT Jobs as well as Systems Manager, Patch Manager in order to patch your IoT devices and your edge devices. You've got to secure the edge gateway. So in case there are open ports, you've got to close any open ports on the edge gateway that are not used. If you've got credentials on the edge gateway, you've got to secure the credentials on the edge device by using secure elements. If you're using secrets on the edge gateway and the edge device, you've got to protect the secrets, and you can use AWS Secrets Manager. You've got to ensure that the edge gateway and the edge device establish secure connectivity to AWS, and AWS offers a number of services in order to securely connect to the AWS cloud. You may also need to secure remote access into your edge device, and you can use the IoT tunneling service. It's important to encrypt data at rest on the edge gateway as well as data in transit. We discussed audit and monitoring of the edge gateway, and we looked at 2 different services, AWS IoT Device Defender in order to audit and monitor your fleet of edge devices. We looked at Security Hub in order to get a consolidated view of security across the attack surface, across your edge and cloud environments. If there are anomalies detected, you get an alert and you can take mitigation actions. And finally, a number of services for backup and recovery. And when you think about backup and recovery, it's also important to back up and recover your edge gateway configurations. So when working with AWS and implementing industrial IoT solutions on AWS, it's important to understand the shared responsibility model. The shared responsibility model is that security and compliance is a shared responsibility between AWS and the customer. This is commonly referred to as security of the cloud versus security in the cloud. So AWS is responsible for securing the AWS global infrastructure, and customers are responsible for their data and applications that they put in the AWS cloud. It's also important to understand the shared responsibility model for the edge. So when using AWS Edge software and using AWS Edge appliances, AWS takes on additional responsibility for securing that software and appliances that runs on the customer premise. As you can see, some examples here include AWS IoT Greengrass, Outpost, and the Snow family that we discussed earlier. And this includes any communication agents that communicates to these devices, as well as identity and access management. Finally, in order to learn more, we've got 2 different assets that I'd like to share with you today. We've got an AWS IoT Security workshop and a builder session. So over here, you can see that we've got an industrial IoT security workshop. So if you'd like to get hands-on and try out these services and get familiar with how to secure the industrial edge, we have an industrial IoT security workshop, and it addresses the first use case, or the data exfiltration use case. So as you can see over here, so this is the architecture that we reviewed, reviewed earlier for the data exfiltration use case. You can use this workshop in order to get hands-on experience with securing your industrial edge solution. We also have a builder session. So in this builder session, it's about building security defenses for edge computing devices. And this covers the second use case. So in terms of cryptocurrency mining and detecting cryptocurrency mining on edge devices, we've got another asset, a builder session that walks you through how to set it up and how to secure your edge devices from cryptocurrency mining threats. So with that, I want to thank you for joining us today, and I hope you enjoy the rest of the event. Thank you.